Hi, this is Kaihan Noyon. In this video, I talk about loops in algorithms. Here's the content. Introduction, loops with specified repetition rate, loops with unspecified repetition rate. Introduction, and here I introduce loops briefly. What is a loop in algorithm? For solving most of problems or questions, we face operation that needs to be repeated. And these repetition performance are particular. Imagine that you want to calculate average of 100 numbers. To do so, it doesn't seem logical to declare 100 different variables as input and then calculate summation and average. This is the time to use loops. Loops are those part of algorithms that makes this repetition of operations possible. Generally, there are two important things that every loop should have them. The first one is having counter, and the second one is condition for controlling the repetition rate of the loop. I explain loops in this flowchart. This is where the loops begins to work. After giving primary value to the loop's counter, we have operation that needs to be repeated. Then we change the value of counter. For example, we subtract, multiply, divide, and some other operation. We use some other operations to change the counter's value. Next is condition for controlling the repetition rate of the loop. This condition here checks whether the value of counter is equal to its final value that was given or not. If the condition was true, operation is repeating again and again till the counter reaches to its final value, or simply it can be said that till when the condition was true, operation keeps repeating again and again. And if the condition was false, the action of repeating will be stopped, and running or compiling sequentially goes to the next lines or next part of the algorithm. Loops with specified repetition rate. Loops that have these 5 features are called loops with a specified repetition rate. The first one is having counter. Second one, primary value for the counter. Third one, changing counter's value. And fourth one, final value of counter. We have to give the final value for the counter. And finally, the last one is condition for controlling the repetition rate of the loop. Here's an example. Write an algorithm that takes n number as input, then calculates and prints summation of 1 till n, or 1 to n. Here's the algorithm. We have to begin writing algorithm. Begin, read n. Here we give primary values to both variables. The first one, which is I, is counter, and the second one, which is s, is our variable for summing numbers from 1 till n. Next, we sum the value of I with s and put it inside s. We do so because we are told to sum numbers from 1 to n. That is why we should give value 1 to our counter, and in fourth line sum it with s. Next, we change the value of our counter by adding 1. At third line, our counter value was 1. Now here in the fifth line, it becomes 2. Sixth line, we have condition for controlling the repetition rate of the loop. It checks whether value of counter is equal to n, which is final value of counter, or not. If this condition was true, then operation of summing, which is in fourth line, repeats once again, and it keeps repeating till when the value of counter reaches to its final value. And then print and we end our algorithm. Here's the flowchart. Begin, read n. We give primary value to both variables. We just sum it with our variable for summation. And here we change the counter's value. Here we have condition. Let's follow the yes part, or the yes path. Here's the operation that needs to be repeated and keeps repeating again and again till our condition becomes false. And here's the no part, or the false part. We print s, or our summation. And here our algorithm ends. Loops with unspecified repetition rate. Every loop that has these two features are called loops with unspecified repetition rate. The first one is having counter, and the second one is condition for controlling the repetition rate of the loop. Here's an example. Write an algorithm that takes a number as input, then calculates and prints number of its digits as output. Let's begin writing the algorithm. First line, begin. We should declare a variable to count number of digits. So count do that stuff. Third line, we give number and our algorithm stores it inside n. Next is an operation which needs to be repeated. This operation is dividing the number by 10. Then we change the value of counter by adding 1 to it. Sixth line, we have condition that controls repetition rate by comparing current value of number with 0. If condition was true, operation which is dividing the number by 10 keeps repeating till it becomes smaller than 0. And next line, we print count. And finally, last line, we end this process. Here's the flowchart. Begin, count equals to 0, or we put the value of 0 inside count. We read the number. We divide the number by 10 and put it back to n. We add 1 to count and put it inside count. And here is our condition for controlling the repetition rate of the loop. Here's the no part, and here's the yes part. And this is the operation that keeps repeating again and again till our condition becomes false. Then here's the no part, which is printing the count and ending our algorithm. Thank you so much for watching this video. Please do not forget to subscribe, and I hope you could learn something from this video.